What's up? What's up? It's your man Jimmy Chan. So today we're talking about logarithmic and exponential equations. So some of the type of equations that you're gonna see that you're gonna need to solve, and you gotta have to kind of come up with some strategies here. Okay. So this first one here has a log on one side and then just a number on the other. So how do I go ahead and do that? Well, this is where you can either use opposite operations, or you could convert from log form to exponent form, right? So if I was to convert, right, the 2 says, I've been your base for so long, I'm going to be the base on the other side, right? So I'm going to do one of these, and then the log is so depressed, it goes away. So essentially, let me go ahead and write that down as something 2 to the first, right? So now I have an equation of 4x minus 6 is equal to 2. So 4x is equal to 8. And x is equal to 2. Now, before I circle this as an answer, I want to go ahead and plug 2 in for x and see if I'm going to be forced to take the log of a negative number. If I am, then I have to reject this answer and have no solution. If not, it's okay. I'm going to be, if it doesn't, then that would be my so-called answer. All right. So again, this would be going from log form, convert, log form to exponent form. Okay? All right. What if I have this right here? So my goal is to, if I can get it to just one log, then that's what I want to do. Okay? So in this case, same thing. I could get this down to one log, because what I see here is I see 2 logs with a subtraction here. Well, what does a subtraction mean? Well, since the logs are on both the same side and just a number on the other, right? I can combine these by condensing them. And since it's subtraction, it must mean it's dividing. So I got the log base 4 of the x plus 1 divided by x. And that's going to equal to 4. Now I can convert this to exponent form, right? Don't want to be a base anymore. I'm going to be the base of the other side, right? So I'm going to have x plus 1 over x equal to 4 raised to the 4th. And if you want to know, let me change that to, I don't know, blue. So, and change this to blue, because those are the 2 that are the bases, right? So what I have here is a x plus 1 over x is equal to, what is that, 128, 4 to the 4th. Let's see here. 2, 3, 4. 256, sorry. 256. Which is going to be, I'm going to multiply both sides by x. So I'm going to have x plus 1 is equal to 256x. So 1 is going to equal to 255x. So x is going to equal to 1 over 255. And there I go. All right. Just double check on my math here. Yep. All right. And again, when I check this answer in here, right, I'm adding 1, so I'm still in positive. I'm taking a positive 1 over 255, so I'm still good. So, all right. What if I have LNs on all of them, right? So in that case, well, first of all, I can't just add these, right? So it has to be, if you look at the rules, I have to have a single ln on one side versus a single ln on the other. So when I combine this, right, I got addition here, right? That means to multiply. So I really have the ln of x times x plus 1 is equal to the ln of 2, right? So now that I have ln of something is equal to ln of something, that means these somethings must equal to each other, right? So with that being said, I have to FOIL this out. I mean, distribute this. So I got x squared plus x is equal to 2. I have a quadratic, so I have x squared plus x minus 2 is equal to 0. So I have an x plus 2 and an x minus 1. So I got x is equal to negative 2 and x equals to 1. Let's see here. If I put the negative 2 up here, this is forcing me to take a log or a natural log of a negative number. Yikes. No can do. What if I put a 1 up here? Okay. That works. That works. Awesome. I can keep this as an answer. Now, don't believe the hype that just because it's negative, I have to reject it. That is not the case, right? Because what if this was plus 5, right? If this was plus 5, or let's say this was x plus 5 as well, then the negative 2 won't make it negative. Okay, so please make sure you're careful with that. All right. Now comes the question of what if the bases can't be the same? Then what do I do? Great. This is where we're going to use either the common log or the natural log. Okay, it doesn't matter which one. I tend to use the natural log more, right? So what I'm going to do now is I'm going to just take the natural log of both sides. So notice that I'm just doing this. Taking the natural log of this side and the natural log of this side. When I take the natural log, I have a power rule, meaning that this power right here and this power right here becomes a coefficient. So I'm going to have an x minus 2 times this ln of 5. And that's going to equal to this 3x plus 2 times the ln of 3. Okay, that's the power rule, right? The power becomes a coefficient, which I have. Now, these are equations, so essentially my goal is just to solve for x. So that's what I have to figure out. Okay, now, one of the things I always like to lead you guys with is this. What if this was a problem, right? Let's say that I didn't learn ln and I was doing this problem right here, right? If I was to do this problem right here, actually, you probably see it as this right here and this right here, right? What if you were doing that problem right there? How would you go about doing it, right? If you know how to do this problem, then you know how to do this problem. It's the same exact thing, right? Because ln of 3 is just a different number than 3. It's still a number though. Understand that, okay? So that's all it is. So let's go ahead and delete that. So you would have said, hey, I can do that by distributing first. Great. Then let's go ahead and distribute. So I got x times the ln of 5 minus 2 times the ln of 5 is equal to 3x times the ln of 3 plus 2 times the ln of 3. Great. Great. So now what do you notice? I notice that I have an x term here and an x term right here, right? So I want to get all the x's on one side. So I'm going to bring that 3x ln 3 over to the left. And now I'm going to bring this number right here, which is just a number, over to the other side. So now I'm going to have this, right, minus this, right, because I got to bring it to the other side. Oops. And that's going to equal to, when I add this over, it's going to be positive, right? So that's going to be that plus this. There we go. Over on the left-hand side, I'm going to have a GCF of x. So if I take that x out, what do I have left? I'm going to have an ln of 5 minus 3 ln of 3 is equal to this whole thing here. Well, how do I get x by itself? Well, x, ladies and gentlemen, is going to equal to this divided by this thing right here. And there you go. So the question is, do we have to plug this into the calculator or not? Well, majority of the time, what's going to happen is that they're going to ask you for the exact answer. So this would be the so-called exact answer. But yes, if it was to ask you for an approximate answer or where to round it to, then you would want to type that into the calculator and see what you get. All right? So what if you had a problem like this one here? Then what do you do? Well, here's the thing. If I said to you, 8x squared is equal to 5, what would you do? Would you try to take the square root of both sides? No, you would not. You would first divide off the 8 first and get the x squared by itself. Then you take the square root of both sides. Is that right? Okay, great. Well, if that's the case, then guess what? We would do the same thing here. So we would divide off that 8, and I'm going to get 5/8. Okay? Now, I know the fact that I can't make this the same base as a 3, right? So what I would do now, actually, let me do it this way. Let me keep this right here and just duplicate it so that I can show that now I'm going to take the ln of both sides. Now, you can use log if you want to, but I'm going to take the ln of both sides. So on the left side is going to be the x ln of 3. And that's going to equal to, well, what's going on the left side? It's division, right? So what, don't I really have an ln of 5 minus the ln of 8? I do. Then I just have to, in order to get x, well, what's x equal to? Isn't x just equal to this right here divided by ln of 3? And this would be my exact answer. And there we go. All right. Well, I hope all of this helped. If there's any questions, please let me know. See ya. Bye.